Yes.
3 forces?
3 force theorem, yeah.
3 force theorem. Okay. Can we see this okay?
Yes.
It's okay. Well, I'd like it at least a bit higher. There now. That's nice. Perfect. Okay. Right, so what's the first question in the 3 force theorem? Andy, you can give it to me.
Kilogram mass
Yep.
hangs from the ceiling.
Yep.
I mean so two strings which make an angle of 40 degrees.
40?
Yeah.
Okay. 40
degree
and 50 degree.
with the vertical.
With the vertical?
Yeah.
Ah. So that means this is 40 and then this one's 50. But in fact, if you got it the wrong way around, you'll still get the right answer. What else?
Find the tension.
Okay. Find the tension in the strings. Right. So, if you were to zoom in here on the ball, you know that you have your weight, of course, which is 50 G. You have a tension and you have a tension. Yeah? Now you know that these 3 forces, they must meet. Where will they all meet? In the middle here, yeah. So this is a 50 G. And then if you think about it, if that's 40, what's this angle here? What's this angle? If I was to draw a triangle here, if that's 40 and that's 90, 50. And likewise, what's this one here? 40. So this one would be T cos 50, and here would be T sine 50, and then on the other side would be S cos 50, and then going up would be S sine 50.
No, sine 40. No.
Thank you, Mishri, 40. Okay, so we can say T cos 50 must equal S cos 40, and also T sine 50 plus S sine 40 must 50G. Now, if I just take out my calculator. So cos 50 is a number, of course, 0.6428t. Now, what I'm doing is I'm taking this to the left, so that would be minus cos 40. 0.7660 s equals 0. And then for this one, sine 50, 0.7660 t plus, I think this would be 0.64, it would have to be, let me just double check, sine 40 plus 0.6428 s, that must equal 50G. 490.5. So this is one equation, and this is the second equation. Now, what should I multiply each equation by? If for example, if I want to cancel the s's, what could I multiply this by, and what could I multiply this by? Any ideas? Or the t's, whatever.
Multiply the in the
Oh, you can do it on the calculator, yeah.
yeah.
Huh? Yeah?
Multiply the pairs by 0.64.
Yep, multiply this by 0.6428 and this one by 0.7660.
We can sub the value of s into the second one. First we find the value of s.
in terms of T.
Yeah.
Yes, you could use substitution if you like. Yep. You did it like he did. Great, okay. So you can use substitution or you can use elimination. It feels like you prefer to use substitution. So what you did was you got the S, was it?
T is 37557.
Let's have a look. I'm not going to solve it because it's a maths problem, not a physics problem. You can use substitution, you can use elimination. So I'll give you just the answers. T equals 375.7 and then S equals 315.3 newtons.
We have to love it or we just want to...
You have to solve it. I'm being lazy.
But we can...
I know. But in the exam, they want to see it. Yeah. Who taught you how to do this on your calculator?
In my school,
Oh, in your home school.
everyone do it.
Oh, I see. Interesting. All right, that's question 1 then. Yeah. So Mir and Mushari, you use substitution to solve this. Did anyone use elimination? No.
We know how to do it,
Yeah.
but it's like it's bit easy than the.
This is maybe a little easier using substitution. Yeah. Okay. Yes.
Why this person has to draw in that way?
Why we draw it this way?
Yeah, I think it's only one word. So it's this will in the word.
How did you draw it? No.
Why?
Why?
Yeah.
Because, read the question, I'll give you the key word. Have you got the question?
Yeah.
Now, so listen, I'll tell you the why.
50 kilogram mass hangs from the cell.
Stop! That was it. A 50 kilogram mass hangs from the ceiling. That's the ceiling.
Yeah, so
Oh,
it will
so how could-
yeah, it will be like that.
Like this.
Yeah,
But that's the ceiling.
yeah. So
But that's the wall.
yeah, it's same.
Oh, it's not the same. It's not.
Yeah, but in this way you can see.
Yeah, but then this should be going down.
Oh yeah.
Yeah. Yeah.
So.
So, look. Whoops. Adnan.
Oh, sorry.
Look, this wall and that ceiling. So if it hangs from the wall, it would be like this. But if it hangs from the ceiling, it would be like this.
But I think it's not different because the ceiling is also.
No, we don't say that. We don't say that in English. Yeah, I don't know, maybe in Arabic or Vietnamese, is it the same word for both?
No.
No, so this is wall and this is ceiling and this is floor.
Yeah, but
What?
so this will be 50
Yeah.
G.
Yeah.
Yeah, so it's different from your picture.
Different from my picture? No, it's the same. There, see 50G.
But the wall.
And the ceiling, this is the ceiling.
Yeah. Yeah.
Trying to.
It's okay?
Okay.
Okay, alright, alright. No, it's okay. It's okay. Alright. There you go. Stop better? There's my ceiling. Alright. Now, what's the next one about? Is it hanging from a wall, or is it a ladder, or what is it? Do you have it, Andy, please?
12 kilogram load for length 1 meter is hanging by means of 2.
Okay, it's 12 kilogram what? Rod?
Rod.
Yep.
Yep.
And it's hanging?
Yeah.
Ah, by 2 strings
Yeah.
from the ceiling. Yes. And what else are we told?
1 meters.
Both are, the strings are 1 meter?
Both strings are 1 meter.
Yeah.
And the rod, do we know how big?
Yeah, 1 meter.
1 meter.
Ah, okay, so everything's a meter, that's handy. And this is 12 kg. So this is 1 meter, this is 1 meter, and this is 1 meter. Yeah.
Each string is attached to one end of a rod, and the 3 ends are attached to the same point on the flat ceiling.
Great, okay.
If the strings were like straight lines, would it make a difference?
They are straight lines.
No, like,
Yes, it would.
so how can we know that they are straight or?
Because I think that I said both of these are attached to one point, did I?
Yes.
Yeah. Oh. Yeah.
Yeah.
Yeah? Yeah. Now, in fact, I know that the ladder is 8 meters from the base of the wall, so the ground here is 8 meters, which means this has to be 6 meters from Pythagoras. So if I call this angle here alpha, I know that alpha equals tan inverse 6 over 8, which is the same as the last one, isn't it? What was that, 36? Okay, and what else now, Andy?
The ground is rough and provides
A friction.
friction,
Yeah.
so that it does not fall.
Good, okay.
What is the angle of the net reaction
Yep.
force at the base of the ladder?
Mhm.
This force includes the normal reaction and the friction force.
Yeah.
What is the magnitude of the net reaction force at the base of the ladder?
Good, okay. So I basically want the angle and the magnitude of the reaction at the base of the ladder. Anything else I want?
And see
Oh,
how much friction does the ground provide.
okay, and I want the components as well. So I basically want everything here, is what I'm looking for. Okay, so let's zoom in a little bit. We know that the 3 forces, they must all meet dot 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 and dot 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 dot. So I know that they all must meet here, for example. Now you can use a little bit of algebra to help you out here. So this alpha, you know what it is. Let me write it in. What did we say it was? 36 36.86. This is 90, so you know this angle is 90 minus 36.86, which is 53.14. Now, what else can we know? Can we know this angle here?
They are minus 90.
Very good, minus 90. So we know that this angle up here is 36.86 degrees.
Yeah.
We know that this is 90, don't we? So can we know this angle?
Yeah.
We can. We can know this angle. It'll be 53.14. Yeah. So I'll just write a little arrow pointing here. That's 53.14. What other angles I'm trying to get to this angle here, which I'm getting close to now. If we know that's 53.14, can we know this angle?
Oh,
53.14 minus 180.
Very good. 180 minus 53.14. So I know this big angle in here is 126.86 degrees. Great. Now we're getting close. If I have this angle, then I can get this angle. Do I have this angle or do I have this angle? I know.
What is 180 minus?
Which one? This one?
Yeah.
No.
The one you have written 126.
Oh yeah, that one is 180 minus the 53.14. Yeah. I'm worried that to continue I need to use a trigonometry rule, which you probably haven't done yet in maths. So I'm trying to think, is there a way I can do it without that? I haven't looked at any of the distances yet. You know, actually, we also know, I'm sorry it's getting messy, we know how big this is. Can you see that?
The line?
Yeah, this line here I'm drawing, how big is that? And remember, this is the center
That's
of
5.
gravity. No, this height?
Yeah, it must be 5.
No, this height?
3.
3. Because it's half of 6. And likewise, I know how big this is. How much is this?
4.
4. So if I draw a little triangle here, this is 3 and this is 4. Can we know this angle here? Yeah, we could know this angle. If I know this angle, and I know this angle, then I can get this angle.
This is
It is. Well, it's the last one. So, what's tan inverse 4 over 3? That's this angle up here. What's that? 53. Okay, great.
50.13.
Yeah, so can you see this angle here is also 53.14. Oh, of course. Never mind. Right, so we know this angle. We know this angle. So finally, we can get this angle. 180 minus 53.14 minus 126.86. No! 0.
Wait,
Yes?
I think
It should be 3.4
Yeah?
3
over 4.
Is the mistake?
Yeah, it's 3.
Yeah, but I'm looking for this angle, not this one. That's why I wrote 4 over 3. Opposite over adjacent. What went wrong? What went wrong? 53, 90, 53. Not happy. Not happy.
I have a question here.
Yes.
Why do you pick the 3 as the
The height?
base? It may
Uh,
be the 5 in the other side.
This is 3, this is 4. Why is it?
How did you know the 3 is the adjacent? It may be the 5 in the right.
Well, this must be the 5 because
Yeah,
it's the longest.
Yeah, I know.
And this is 3
Oh, okay.
from here. I made one small mistake. I can't see what it is. Can anyone spot it?
If it's 53.14, that the other side would be 53. Why we have written 36.86?
Huh? 30. Hang on, I'm confused. Let me go back in time. Am I sure that's 126?
180
Yeah, it looks like it.
minus 153.14. It's 126.86, yeah?
Yeah. All right. Let's go back in time. Let's start it again. I've gotten too messy. Okay. Let's be more careful this time.
What?
Yeah, you found the mistake? I'm starting again. Okay. No, don't worry. I didn't get it right. I'm not finished. Right. Okay. Let's be more careful here. So I'll just draw in the lengths, no forces. Okay. So here to here, that's 10. We're all happy with that. Yes? Right in the middle here, if I go down, this is
4 and 4.
4 and 4. Yeah, and then if I go across here,
3.
oh, maybe that was the mistake. Is it 3 and 3? Yeah, it's in the center. Yeah, because this is 5 and this is 5.
Yeah.
And if that's 4, that has to be 3. And if that's 3, that has to be 3. And that's 4. Yeah, okay. So that's 4. Okay, nice. And then I had my force going from here to here, and then from here to here, and then from here to here. Okay, and I know that this is 90. Great, okay, this doesn't look too bad now. I want this angle. Okay.
It will be 15 times 20.
Oh, you got it. Good. Tell me what to do next.
In the last, yeah.
Oh, well, let's start with this one because it's clean.
Okay.
Yeah,
Wait.
let's see. We would...
We find the,
Top one here?
yeah, we find,
This one.
yeah, in the last,
Did we find it?
yeah.
I don't think we got this one.
Yeah, it's,
Yeah,
We
it's,
did it 53.
Oh, we did get that
Yeah.
one.
yeah, I think this was not right.
Yeah, it's 53.14.
it's 56.87.
Oh, okay. My mistake was with this angle. Oh, okay. Well then, and I forget, how did I even find this angle?
It was by tan inverse 4/3.
Yeah.
Oh, because I drew another triangle here,
Yeah.
was it? This one is 3. Oh, here's my mistake.
And that will
This
be,
is not 4.
This is 5.
It's less than 4 because
Why we-
4 would be to here. Yeah. Yeah. Okay, let me just think. I can do this.
we can take
Yeah.
180 degree
Yeah.
minus 126.86
Mhm.
degree and minus
Mhm.
36.87.
This is 36.
Yeah, it's 36.87.
Yeah, but how did I get this? But I think that's wrong.
No, the 36 is the one.
It is.
No, this one is 53.13.
All right, now hang on. Let's just forget the last time I did it, okay? And let's just look at this time now. All these numbers are definitely right.
Yeah.
Okay, so what we want to do is to get this angle, and we can get that if we know this angle and if we know this angle. And we can let's start writing in angles that we know. So we know that this one here, this is tan inverse 3/4. That's the 36, is it? Yeah, no, I'll just write 36, or I'll just write 37. 37. And this is 90. And this one here?
53.
That one's 53. Okay, and that's 53. And this one? That's 90. And this one here? That's 37.
No, this one is.
No, that is 37.
3/4,
Yeah. And this one here?
53.
53. And this one here? 90. And this one here? 37. And this one here? 53. And here I can get this because these should add up to 360. So 360 minus 53 minus 37 minus 90 minus 53. So this one here is 127.
We got that last time.
Good.
Yeah.
Good. So the problem is just to get this one.
I think this is 53.
Ah! Got it. We haven't looked at this triangle.
Yeah.
So it's 53 then.
No, because if we look at that big triangle, what's the height?
6.
And 4.
6/.
Ah, so I could have done this at the start because this is 6.
And this is 4.
This is 4, and I can get this angle, which is the one that I want.
56.
Without all.
Without all of this,
I'm very confused.
I could have done. Ah, that was stupid. Alright, sorry. Yeah, well, this is good because then if it comes up in the exam, you won't make this mistake in the exam because I made it. Right? So, let me just redraw it neatly. So this one here is 4, this one here is 4, this one here is 3, this one here is 3, and this meets here, and it's like this, and what I'm doing is I'm looking at this triangle. You see this one here?
Yeah.
So the height is 6 and the base is 4, and I just have to do tan inverse that. And that was all I had to do all along. 56.3. That was all I have to do after all that waste of time. That's terrible. Alright, so now it looks really easy.
Yes.
Yeah.
But
Okay.
Before it was like
Uh,
hard and now
Yeah, I
it's
know. Last time was a mystery. Okay, so the first part was to get the angle, which we now finally have done. Simply by just doing this. So I'll just draw the forces. Can I go down a bit? Yep. So what was let's just draw the ground again here. So now we know that the ore that goes this way, there's two parts. This one, which is ore cos, what was it, 56.3, and then this one here is ore sine 56.3, and then don't forget you have a force going this way, which is F, and then we had a force going down, what was it, 10G? 20G. Right, so let's see what equations we can make. We can say S must equal ore cos 56.3 and ore sine 56.3 must equal 20G. Great, so will this give us the ore and the S? Yeah, it will. What should I get first? Ore or S? Which one first? Yeah, I can get the ore first. So here I get ore equals 235.8 newtons. And then this easily gives me the S. 130.8 newtons.
Can we see the symbol?
This is what you want to see?
No, the triangle.
The triangle? This one? Ah, dude, I thought you wrote this down, no? Ah, no, I need to go on. I spent way too much time on this triangle. Right, so we have a force this way of ore cos, and we have a force this way of ore sine. The ore cos is 235.8 cos 56.3. So this is 1.8 newtons, and the force going up is ore sine. So if I just change that to a sine,
This is 23.8, not 1.
20. What's 23?
235 newton. This is
0.8.
yeah. This is here, not 130. On, you know.
Oh, I drew it the wrong way around,
Yeah.
was it? Ore cos is on the ground. I think that's
You give the
right.
S, the value of the
S? Yeah?
S is 130.8.
Yeah.
You did it for the R.
I did it for the ore.
Yeah, and
Firstly, are you happy with me saying this?
Yeah.
This is right, okay? And this is right?
yeah,
Good. So is this right?
yeah.
Okay, and then what I did was I put that in here.
No. When you draw
Oh, when I draw?
in the right.
Yeah. Oh yeah, this one is this.
Yeah.
Which is the same as S. So this one I just typed in ore cos 56 and I got 130, and then this one I typed in ore sine 56 and I got 196.2. Yeah. Okay. And probably that's everything. Yeah. So by the way, just for vocabulary, this force here is called the friction. It's the one when you like rub your hands together.
Or with your legs.
Yes.
On the
This
line.
one is the friction, and this one is called the normal reaction. And this one in the middle, I guess you can just call it the reaction then. So for vocabulary, that's the three parts that we have.
This section
Yeah, the ground is the friction, because it stops the ladder from sliding. Yeah. Okay, that's the end of that one then. And I think the next one is work, isn't it?
Yeah.
Yeah.
We will not use the lab. The
Huh?
lab like not the computer lab, the other lab, the science.
Yeah, we'll
lab.
use that.
Well, next year.
But what's that got to do with this?
Uh,
Nothing. Nothing. So we're not talking about this.
So, and
Yeah. Right, can I close this one now? Yeah.